All right, we're going to go ahead and get started. What an awesome turnout. Thank you all for coming. Welcome everybody to our Entrepreneurship Speaker Series. This is our 12th time that we've been doing this in the series, and we've had some incredible speakers for those of you that come to this series regularly, including Nobel Prize winner Carolyn Bertazzi of Stanford, and most recently, Oregon's own Janice Weeks, who founded In Vivo Biosystems, among others. If you are interested in, if you haven't been to all of them and you're interested in seeing some of the past ones, most of them, if the speakers aren't presenting proprietary information, things like that, we have recordings of them that are on the website, so you can go back and look at those. So I actually first met today's speakers, Chris and Fenella, when they attended another of the talks in this series. So they were here 18 months ago to see Chris Gibson's talk, and the title of that was Serendipity of Failure. And he shared many lessons on how to fail fast in your startups and sort of pick yourself up. Don't let, as the Phil Knight quote says on the wall, don't let anybody call your ideas crazy, just keep going with them. And he talked about the challenges of startup companies. And I'm so grateful that Chris and Fenella came back and are going to share their story with us tonight. Really eager to hear about the tale of two startups. They're going to share their experiences with actually several startups. And let me tell you, if anybody tells you who's been a serial entrepreneur, and I think a lot of entrepreneurs have done several startups, if they ever tell you that everything went perfectly and all their startups, were successful, they're probably lying. They're probably at least not telling you the whole story. And so tonight, I think we're going to, this morning, we're going to hear, I think, about some that have been very successful and flourished, and others that have somewhat floundered. But a common thread really of this is really building through perseverance and resourcefulness. And as Chris and I were just talking about, people is really in the end often a main factor that determines success. So let me introduce our speakers. Chris Raymond has been active in molecular biology for over 35 years. He is both a banana slug and a duck. I had to look up what a banana slug was, I have to admit. Receiving a bachelor's degree from UC Santa Cruz and his PhD from the University of Oregon, where he was a graduate student in Tom Stevens' lab in the Institute for Molecular Biology. The opportunity to participate in the Human Genome Project in 1999-2000 inspired his passion for nucleic acids technology and the ways in which genomics could address unmet needs in human health. He recognized that the advent of next generation sequencing opened many opportunities to apply genomics to population-wide clinical applications. Now, Fenella Raymond, arguably the better half of the two, has over 25 years of experience in both academic and biotechnology settings, including as a technician in Alice Barkin's lab here in IMB in the early 90s. Her career in biotechnology has encompassed being a program management research and development at several companies in Seattle. And more recently, she became the successful owner of a Seattle retail business. The opportunity to return to research as co-founder of Ripple Biosolutions was too great of an opportunity to resist. And so she's pleased to be part of the company that develops innovative technologies in cell-free DNA applications. Chris and Fenella live in the Seattle area. They have an adult daughter and son, and like many of us in the Knight campus, several beloved furry family members. You may want to check out our website. We have titles for each of our furry family members. So let me personally thank Chris and Fenella not only for giving their lecture today, but for their generosity to the University of Oregon. They are optimal partners for our graduate programs, providing philanthropic support, both in the Knight campus and in IMB. And they have intense creative hands-on mentorship that they've really generously given to our KCGIP students who have interned with them in their startup companies. And you'll hear some more about that today, I think. So Chris and Fenella, thanks so much for being here. We're really looking forward to your talk. Thank you.
Okay, great. Well, thank you so much, Bob, for that nice introduction. It's really a delight to be here today. Thank you for inviting us to this entrepreneurship speaker series. We're really happy to be here. Thanks everybody for coming. We're just thrilled to be back in Eugene, one of our favorite cities ever. We're happy to be at the Institute of Molecular Biology again and at the Knight Center. So thank you. Today, Chris and I are going to talk about the story of how we became entrepreneurs, how we got here and why. And at the end, we're going to leave you with a few reflections, things that we have learned along the way. Our story is a little bit different than others that you may have heard in this series because we come together, we approach this as a business partnership. So not only are we partners in business, but we're also partners in life. We've been married for, many years now. And this arrangement would not work for everybody, we know, but it really works for us. We get a lot of satisfaction from being in business together.
I also felt like Bob did a really good job giving our talk. We should probably just have him up here, but yeah.
Yeah. No, we really do like doing things together. We like each other's company. We like being together, and it works really very well. And in that same vein, when we thought about how we should do this presentation, we decided to do it as a kind of a back and forth tag team. We take that kind of an approach. So we'll see how that works out. I'll talk a little bit, and then Chris will probably talk a lot. And then we'll go back and forth. So.
And you are in control of the clicker and the forwarder. So this is a picture of the Institute of Molecular Biology that Callie helped us find this. We actually have some original versions somewhere in our house. It was taken around 1990. And there are a couple of elements of this picture that I really like. One of them was while I did my graduate work in Tom Stevens' lab, and that was a delightful experience. One of the things that this picture captures is that the Institute then and hopefully now was a community. And as a community, it was really, it has surprised me how much I learned from other faculty members and students that I've used through the years. So Fenella and I actually ended up in the front of this photograph because Fenella's job was to run around the Institute and corral everybody for the photograph. So there we are in front. We love the mullet hairstyles from the late 1980s.
Yeah, I have to acknowledge that. And when you look at this picture, it's like, oh my goodness, it was the 80s. So sorry about that, but we all proudly wore our mullets. And So I came about a year after Chris started his program, as he said, in 1984. I was finishing up at UC Santa Cruz, which is where we met. Excuse me. And by the time I got here, we were married. And I was lucky enough to start working for Vicki Chandler, who is in this picture right around. There's Vicki. Oh, this is a squirrely dot, but there's Vicki. And just to Vicki's right is Diane Hawley. I also worked in Diane's lab for a little while. And shortly before I left, I was able to work in another person's lab who's not in this picture because she was not here yet when this picture was taken, but that was Alice Barkin. So I was very grateful that I had a chance to work for all of these women. I learned so much and it stood me in good stead going forward.
One of the interesting things about having parents is that the apple never falls far from the tree. My parents were working class people. And so while I was at the Institute, I harbored this dark desire. And that dark desire was not to be an academic scientist. I was the only scientist in my family. Everybody else went on to different careers. I wanted to be in applied science. And I'm so excited to be here at the Knight campus today because what it means to me is an embrace of how science and society and business can all interact. And so I deeply appreciate both this physical space and the wonderful humans that are in it.
And back to our theme of working together as business partners and life partners, this was actually at the Institute was our first experience of doing a project together. Chris and I worked together in Vicki Chandler's lab on a project, and it was really great. It let us realize that we can work together well, that we enjoy it, it's productive. We also had a couple of good examples of married couples here at the Institute. There was Frank and Mary Stahl, and there was John and Charlotte Shellman, right? Yeah.
And both of which managed to escape the photograph.
Yeah, neither one of them.
Right.
Yeah.
But it was, but that was a really powerful thing
It was.
because the message was married couples can work together. And, you know, it was really something that has carried us to this day. After graduate school, this picture is sort of a collage of life thereafter. And a major part of it is we have two lovely children, one of whom is in the audience today. The other lives in Portland, Oregon. And, you know, in an industrial setting, when you have a science job, you end up actually working for many different outfits and have many different experiences. And there was sort of a 20-year blur. One of the major influences for me was working on the Human Genome Project in Maynard Olson's lab. And I actually can't give a talk without putting Maynard somewhere in the slide deck. So this picture is just sort of the blur of 20 years that we spent working in various biotech industry settings and all the things that you assimilate and learn from that.
So all this took place in Seattle. Our life did focus around our children and our jobs because we both had full-time jobs. We were very busy as well as raising the two kids. We worked together, as it turns out, as zymogenetics here. Our times overlapped about maybe a couple of years. And once again, we were able to do a collaboration together. So it reinforced the fact that we could work together. It was fun.
So that picture, we decided to sort of distill it down into the parental lecture. And the parental lecture is that, you know, it actually is a really good idea to go get a job and get a paycheck, which we did for 20 years. And thanks to Fenella's financial stewardship, we were actually fairly stingy and we're good at hiding money from ourselves. And so not only did we get a paycheck, we put money away in 401ks, we garnered an enormous amount of experience in you know what, you were supposed to do this.
Yeah, you were taking my time.
Then I was doing good too. Okay,
Great.
all right, sorry.
Well, I'll just add to that. Yes. This 20 years really did allow us to get a nice, firm financial footing, and that served us well going forward. We did have the two jobs. We had steady checks. We were able to invest in our savings, and we were able to save for our kids' college tuition. So we got all of those financial things out of the way, and that paid off. As I already mentioned, one of the big influences on me was Maynard Olson, and the reason was because Fred Sanger had just announced that he'd figured out how to determine the DNA sequence of 26 bases. And it only took 2 years and extensive effort. And Maynard said, aha, we're going to sequence the human genome. And he stayed after it for 20-something years. And he was a man he lives in Port Orford, Oregon, as a matter of fact. He left me with this indelible notion of think big, think about what you do in science and how it can really profoundly impact humanity. And that even though you're one sole person, you can really make a difference. I appreciated that a lot. And in fact, I carried it to Rosetta Informatics, which was a subsidiary of Merck, where the area of genomics, because the human genome had just been sequenced, was beginning to blossom, and there were a lot of ideas. And what I discovered in that moment is I actually have a talent for taking a concept and distilling it down using molecular biology that I learned here into practice. And you know, I have many, many poor qualities, but that happens to be one of my gifts. As for myself, I was able to take the great experience that I had at IMB and work in Seattle biotechnology companies. I worked, as I did at the IMB, I worked doing bench research, but then I went into program management, which was very interesting for me. I enjoyed it a lot because it allowed me to get a bigger picture idea of all of the things that went into a project, all the different parts that belong to it, such as manufacturing, regulatory issues, specifically with drug development. And one thing that I was struck by was the teamwork that was necessary for a project, and also planning and strategy. And I realized that you don't just jump into a project. You have to have a very firm plan written out, agreed to by everybody, a way to discuss decisions, strategizing, And this was a very good experience for me. And that also has really stood me in good stead as we went forward.
At the end of 20 years, when the kids were packing up to go to college, you end up with this cheeky notion that you can do it better than somebody else. And so we were both inspired to start our own businesses and be in charge of something. And so we went on a destiny of working for ourselves that we've never really given up. The other thing that was happening at the time,
Oh, okay.
okay. The other thing that was happening at the time is having been at the Human Genome Project and having seen the potential of DNA sequencing, next generation sequencing really caught my imagination as being this incredible tool. And it has been an incredible tool, and it continues to be an incredible tool. And I actually sort of carry around that we haven't done, it hasn't seen its best days yet. And so that sort of drives the desire to work for yourself and the desire to exploit this amazing capability in next generation sequencing drives the next several years.
Yeah, so what I was going to say was that we were at the end of this period, we were kind of tired of working for other people. And we just were thinking, what would it be like to have our own business? So we decided when the kids got a little bit older and started going off to college that we would explore that. We went in two different directions, though. We each had our own, we didn't go into business together. We actually each had our own business experience. I kind of took a right turn from science, and I ended up purchasing a local yarn store. But this wasn't just any yarn store. This was an iconic yarn store that had been in Seattle for about 30 years. And I did it because I like to knit. I'm not a really proficient knitter, but it was a hobby. And this was my local yarn store, and it came up for sale. And I thought, you know, this might be a fun business to have, and I'll probably learn a thing or two. So I jumped, and it was very fun. And I did learn a lot. And one of the things that I learned was that having your own business is just all consuming. You have to give 110% of your effort to your business. You are the one who is on call for everything that goes wrong, as well as things that go right. And I don't think I've ever worked so hard in my life. Well, it didn't help with, we decided shortly after I bought the business to remodel the whole thing because it was, as I said, 30 years old. It was in need of an update. So we closed the business and we repainted, we got new carpeting, we got new shelves. We just did a complete remodel. And that was a lot of work, but it was so rewarding. And this picture was taken after everything was completed. And I was really happy. It had a very nice ambiance, really cozy, good place to be. So I was happy with the results. It was all worth it, but it was a lot of work. The other thing that I learned from this experience was people management, about how you might have an idea that you want a particular person to fill a certain role, but then after working with them, that person might not quite have the strengths that you thought that they did. And it was a good skill that I developed during this time to be able to take somebody and identify what their strengths really were, and then to fit them to the position that required those kinds of skills. And it might be different than what you had initially thought. I also got a great experience in working with some of the foundational aspects of a business, such as accounting and inventory management and social media and advertising, some of the things that aren't really that glamorous, but are absolutely crucial when you're starting a business.
And the picture really captures that it was a lovely place to be.
It was.
It was always fun to visit there. Yeah.
Yeah, and I sold it to 2 employees, and it's still going strong, which is great. So nice legacy.
At the same time, my son vacated his bedroom, and so I moved in and set up a laboratory and began to tinker around. And I actually started a company called Ripple Biosolutions with 3 of my ex-Merck colleagues. And we did some good invention in that bedroom laboratory, enough so that we were able to get some in early investment in the company. 2 years later, it's morphed into Resolution Bioscience, which only recently actually went on to be sold to Agilent Technologies. And truthfully, that was a really nice outcome for us. It enabled us to do things that we're doing today. One of the, you're the slide master.
Okay, here we go.
One of the profound experiences that happened during my time at Resolution Biosciences, we took part in this large study that's shown in the lower left-hand corner where we were applying liquid biopsy technologies that I had started in that very bedroom. We applied those to late-stage small cell lung cancer patients. And the incredible thing was 35 of those patients, our liquid biopsy pointed to a candidate driver gene. And that candidate driver gene had a precision medicine associated with it. And based on that liquid biopsy alone, those 35 patients were treated with 7 different driver genes with these 13 different drugs. The 13 different drugs are because the landscape of precision medicine is evolving rapidly. And so they ended up over a period of years getting different treatments. But the part that really changed my perspective on applied science was the fact that 34 of these 35 patients responded to drug. Now, this is a terrible disease. It's a terminal disease, but any kind of response that enables quality of life is a really big deal. And so this is one of those moments where you realize that the science you do can actually have a profound impact. And it made me more determined to be better. And one of the parts about the study that I didn't like is that there were patients that were missed. There were patients that were good candidates for targeted therapy. Sequencing of their tumors revealed where to go, and so they did get the appropriate treatment, but we missed them. And my thought was, as I was getting kicked in the fanny out the door from Resolution Bioscience, I can do better.
So just by serendipity, I ended my time at the art store.
Wasn't me.
Or was that you? I don't know. And Chris left Resolution Bioscience within a couple of months of each other. So we were both looking for something new to do. So we thought this is a good time to take a look and see whether or not we would like to go into business together. And we assessed our strengths. And Chris's strength obviously is in inventing and being innovative. He has these fantastic ideas. And not only is he good at imagining something that's kind of outside the box, but he's also really good at actually putting it into practice in a molecular biology way. My strengths more lend towards the implementation, the practical side of actually putting something together. And then we have a very nice overlap where we can talk about science. We have wonderful business and strategy discussions. So we decided that it would work well. Chris is also really good at making slides, and he made this slide, and I love what he did there on the right-hand side, where he envisions himself as a balloon floating up in the sky with these lofty, wonderful intellectual ideas, and I am the ground to which he is tethered.
I had someone once tell me, "She keeps you alive." So we decided, given the yarn store was passed into capable hands, and given that I was not at Resolution Bioscience, we had a lovely trip to Scotland and then came home and started working on the idea for a new laboratory. And Fenella, actually, the first thing you do when you're going to have a business baby is you name it. And Fenella came up with this name.
Yeah, we wanted to convey the idea that this technology that we knew had so much benefit would not just benefit the person, the immediate person who is receiving the treatment, but all of those people around that person that are connected, that are part of that person's loved ones and family member community. And so we wanted something that would say that when you improve one person's life, many other people also benefit. And so this really did become kind of the ripple effect, but in a medical sense.
And the other cool thing is that somebody else is doing something else in some other corner of the world, and the ripples from them come and flow across your own efforts in a way that you can't anticipate.
So what is cell-free DNA? Since cell-free DNA is kind of the core of our Ripple Biosolutions business, we wanted to spend a little time just talking about what this is. Cell-free DNA, as the name implies, is DNA that is not found in the nucleus of the cells, but it's actually free. In this case, we're primarily interested in it in the blood, but actually cfDNA is found in all biological fluids. It's in the urine, it's in the saliva, it's in lymph tissue and cerebrospinal fluid. all cells of the body, including tumor cells, shed DNA into the bloodstream. And we know that probably, or that most likely it comes from cell death, largely apoptosis. On the bottom left here is a graphic representation of the secondary structure of DNA. You can see that the DNA strands themselves are wrapped around the proteins, the histone proteins. And that DNA histone complex is the nucleosome subunit. During cell death, there's cleavage in between those nucleosomal units. And those individual units are actually what is in the bloodstream. This also explains why we have a uniform size of the DNA fragments. They're about 166 base pairs. Let's see. Oh, so actually it was in 1948 that DNA was detected in the bloodstream. So this was way back before they even really knew what DNA was.
Before the structure.
Before the structure. It was, yeah, in the early 50s. It wasn't until 1966 that they discovered that there are high levels of DNA in the blood that correlate with sick patients. And on the right here is a graph from a paper from 1977 that actually shows the distribution of DNA in the blood in patients with cancer as opposed to a healthy patient or a healthy person here. And in fact, they also recognized that patients who had metastatic cancer had even higher levels of DNA.
So Fenella, one thing that I was thinking about this morning was the fact that this liquid biopsy technology we keep talking about, the core analyte of that liquid biopsy technology is cell-free DNA that we then push through a next generation sequencer.
Right, exactly.
And we didn't exactly, I was thinking, did we make that a connection or not? So anyway.
I think it's actually on the next slide.
Well,
What is a liquid biopsy?
there you go. Hey. Tethered to the ground. So our interest in, and this is an illustration of what we think about with a liquid biopsy, is that tumor cells and normal cells actually both undergo growth and apoptosis, and the apoptosis liberates DNA into the bloodstream, and among other bodily fluids. And the name of the game is to capture that information in next generation sequencing, to convert this biological goo, if you will, into digital information that you can really analyze. And the way you get at that information is if you spin whole blood, it separates into the erythrocytes and leukocytes, which are a cellular fraction on the bottom, and the plasma is actually cell-free. And that's where we collect our cell-free DNA. We're actually remarkably good at knowing how to purify this stuff. And this is a photograph that really speaks to what Fenella was saying earlier, where when you isolate cfDNA from a normal human, you generally see this ladder effect of either a monomer, a dimer, or a trimer. It reflects the cleavage between these histone elements, and sometimes it's incomplete, so you end up with dimers and trimers. And the whole name of the game in liquid biopsies is to convert this biological material using molecular biology into digital information. And that is has so much incredible promise, and it is such a difficult problem. And so that's what we've been doing for the last several years. When I left Resolution Bioscience, I left with the state of liquid biopsies as being incomplete, as I mentioned. And actually, to this day, all of the commercial offerings that are out there, I think, are not terribly satisfactory. And the reason is because you purify, you only get so much blood from a patient. A doctor isn't going to allow you to pull a gallon of biofluid from anybody. So you only get a couple of 10 ml vials, and you have to make the best of it. And we're not making the best of it. In fact, the part that really disturbs me is the fact that about 15% of the DNA that you purify from a patient sample ends up in this digital information, which I've shown as A's, C's, G's, and T's, which is very inefficient. It means that you're leaving a lot of information on the table. The other thing that bothered me was that if you looked carefully at the oncology biomarkers, and I pulled out two of them, one is KRAS and the other is KIAP, they actually define sort of the extreme spectrums of AT-rich and GC-rich genomic sequence. And they were not well represented and are not well represented in current liquid biopsy technologies. And so as a married couple,
we decided to sell the sofa and make our own lab. But I did want to just say one thing about this, which is this was the state of liquid biopsies at the time, back in 2018, but it has not changed that much today. Surprising. So yes, we thought we'll make our own lab. It turns out that we had a lower floor that was our TV room. And we had this lovely big sectional couch there, but we didn't use it very much because the kids had grown up.
It was from Crate and Barrel.
It was a very nice sofa. It was a nice sofa, but it would make a perfect lab because it was a fairly large room. It had a tile floor, so we could keep it clean. It was consistent temperature because it was on a lower floor. So we put an ad in the paper and very quickly answered by two very enthusiastic young University of Washington guys. I think they belonged to a fraternity. So they came and took our sofa away, very happy to get it. And there you go.
I'm sure that sucker has taken on a lot of beer since.
I think it has. I think it lives a happy life, but a very damp life. So we had our home lab. And there we are. And you know, there's a couple of real perks to having a lab in your home. One is that the commute is really great. And the other is that attire can be very informal.
As Callie pointed out this morning, though, I did have closed-toed shoes on.
Closed-toe shoes, and he was wearing gloves. This actually was a really hot summer when we started this lab in Seattle, and he took full advantage of that. But I like this picture, aside from the cute guy that's in there. I like this picture because it kind of shows the put together, not well put together, not flashy, shall we say, nature of our lab. Note the sawhorse in the back. That table was one that Chris had made. He just put some wood together and finished the top so that it made a nice flat surface for a lab. And then we put it on top of sawhorses. We scoured eBay for the best deals for used equipment, and it worked.
Actually, the University of Washington has this surplus store.
The surplus store.
And they sell surplus scientific goods. It was our favorite place
One
to
day
go.
a week you go, people would line up to get there and get the best deals. It was fun.
But there's an important, thank you for bringing up.
And this was our first iteration of our logo. Did you have something more to say?
Yeah, I would say, I think one of the key things that we've found as far as being entrepreneurs is concerned is build your prototype as inexpensively as possible.
Absolutely.
And this was really great. Not only was the commute fantastic, and you could go check on data in the middle of the night easily, but it also kept our costs down. And,
Right.
I think that has been a driving theme for us ever since.
We're quite frugal.
So 3 years of, and I didn't work in my undergarments the whole time, 3 years of working in the home lab. And I actually managed to make significant progress. And the significant progress is in the form of being able to change the amount of information from patient DNA that was ultimately present in a next generation sequencing run from about 15% to about 75%. So that's really about squeezing about as much lemon juice as you can get out of the lemon. And in addition, again, I managed to change using molecular biology. And I shout out to Pete Von Hippel. There's a lot of Pete Von Hippel in this. It's amazing how you can channel people and you realize you actually did listen when you were in graduate school and you did learn things and they become useful sometime later. We managed to recruit this KRAS and KIAP, which were on the extremes of genomic analysis and or genomic composition. And one of the interesting things is there's actually now a drug that is targeted against KRAS. It isn't terribly effective, but important nonetheless. And so, of course, my better half made the declaration.
We said, let's do a second business. One was not enough. So in 2021, we did start another business. We decided to found a new company that would take the liquid biopsy assay that Chris developed and apply it strictly into the area of oncology diagnostics. But we decided to take a different approach with this one than we had with Ripple. Instead of doing it ourselves, we decided that it would be a good idea to hire a management team. We wanted to accomplish one primary goal, which was to become a CRO that could provide physicians with data that they could then use to determine or to get a better idea of what the status of their patient's cancer was. and that they could then use also to help diagnose and treat that cancer. So that was our primary goal. And we thought that having a professional staff in place would really be the way to go, that it would get us there faster. We really wanted to get this great technology out to be used as soon as possible.
And remember, one of the lessons from Resolution Bioscience is once the inventor's done inventing, they're not very useful and it's time for them to get out of the way. So we were trying to learn from that basic lesson.
Exactly. So we were able to do that thanks to the sale of, as Chris mentioned, of Resolution Bioscience, which happened a few months previously. We started this company in 2021. And about a year later, we did a seed round, and it was very successful, in part due to the really beneficial and good, very friendly capital market at the time. However, it took longer than we had anticipated to transfer and to set up this technology in the new company and to set up the liquid biopsy assay and the lab. So very sadly, during the time of this that it took to do this, the funds that we had raised were exhausted. And this very unfortunately coincided with a change in the economic landscape. No longer was very friendly to new startups. There was basically no funding at all available. It had essentially dried up. So we had
as a partial person in the business realm of biotechnology, the carnage in the last year has been absolutely spectacular. Yeah. It is amazing what has happened to funding, and
it's changed so quickly.
Yeah,
it really has. So we had to make the very difficult decision to cease all operations in the company and to just completely restructure it. And this was really disappointing to everybody that was involved, obviously, but we remain committed to the technology. We know that it's very beneficial, and we are still actively pursuing commercializing this technology.
And I think one of the things that you and I have discussed while we were practicing, one of the things that we have discussed is, one of the important lessons of being an entrepreneur is not everything works. Mm-hmm. And if you can't stand failure, don't do it, because, we're dumb enough to dust ourselves off and get back in the saddle and do it again.
It depends how you define failure. I wouldn't say it was really a failure. I think we learned a lot. It didn't work out like we had hoped, definitely, but it wasn't a failure because we learned a lot.
So my kids are wondering when the parents are going to chill out, and it isn't going to happen anytime soon. And in fact, while we were working our way through this whole flourished biotech thing, we were also still running our little company, Ripple Biosolutions. Ripple Biosolutions, it's a really interesting, again, business comment that the liquid biopsy market, just thinking about cfDNA, is in the tens of billions of dollars, and yet you cannot buy anywhere purified human cfDNA. This is the core thing that goes into the assay, and you can't get any. So one of our core products is in recognition of that, and actually driven by our own financial need, where I was spending way too much money on QIAGEN kits. We invented a method to bulk purify cfDNA, and it's one of our core products that's advertised on this website. And then as the story, this is the last chapter of this story, but as it progresses, we've actually been drawn by customers into other market areas, other business areas that we did not anticipate, hence the Ripple, with this as a core product.
Mm-hmm. Right. So going back a year or so, we did, as we said, work in our own home, have our own home lab. But then we moved our house, and our new house didn't have room for a lab. So we decided that we needed to go and get a lab somewhere else. So we did. And here it is. It's not the RV, thankfully. It's the building behind it. Not much better, to be honest. It was definitely a little hole in the wall, but it sufficed for us. I love the for lease sign, which was there for the whole 3 years that we had the space. It was never in a very good part of town, but it was okay.
Are you kidding? It was Aurora Avenue, which is one of the sketchiest spots in Seattle.
It was a bad part of town, but we felt okay. We were on the second floor. We had a locked door. We felt safe. But as time progressed, it got worse and worse, and the RVs moved in, and the people that lived in the RVs were not just homeless people. They had definite drug problems and medical problems, and there were some really rough characters, and it became not a good place to be. We found syringes in a parking lot, and it became quite obvious that we needed to leave. So early this year,
But nonetheless, we grew our business there.
we did.
And I think that's one of the
Well, that's true.
important stories, is that we actually leveraged this sketchy opportunity into a greater business environment.
We were there for
ourselves.
over 2 years.
And if anybody's interested, we can give you the phone number for
Probably
this
really
startup
good.
lab.
So early this year, I'm really happy to say that we moved into our new space. And it's quite a bit different, and we love this space not only because it's such a wonderful place to work. It has great light, it's in a safe building, ample parking, but we actually designed this ourselves. This had been just a plain office room, and we had them modify it to our specifications. They put in that beautiful floor, they put in new carpeting in the offices. We designed, actually on PowerPoint, we designed where we wanted the lab benches to be, and then we ordered them to those specific sizes, and it just turned out exactly as we wanted. So we are so happy to be here, and we are so glad that our business has grown to that point that we can actually be in a real lab. So
And one of the really
Yay.
cool things about this laboratory, anybody who would be contemplating a science startup, is that all of those lab benches are on wheels. And so when we have a different kind of a project, we can reconfigure the entire lab to be in a distribution of different lab benches. And that's an incredibly powerful feature we find in our business.
absolutely, it allows us to compartmentalize different activities. Some things really do need to be removed just so that there's not any kind of cross-contamination of DNA, and it works really well.
So I'm a weird guy. I love to work in lab. I love, and in particular, when I was a little kid, I was really fascinated with chemistry sets. And this really purifying cfDNA just sort of scratches an itch for me, where there's big boiling pots of water and giant magnets, and it's big. So this is what you can collect from a human being, and it's 800 mils of plasma. So in a single sitting, a healthy donor can sit down and donate 800 mils of plasma at once, and there's cfDNA in there, and it's a very rich source of molecule for our ISO pure cfDNA product. And in fact, the horrible thing is that you can donate something to the tune of twice a week. So and people do, and they pay for their house or whatever. So you start with that amount of material, and I had to invent the process that we use. And what I invented was a magnetic-based process. I'm really interested in your manufacturing lab in the basement. I love the idea of making big magnets. This sucker is huge, and it has some incredibly powerful neodymium magnets inside. You can see in the upper right-hand corner that the magnetic particles with DNA bound to them bind to this array of magnets that's within these circles. And this is sort of custom built stuff, and I'm incredibly grateful that we have these tools. When we produce this product, I have to conform to the rules, and conforming to the rules means that we actually produce a certificate of analysis with every batch of cfDNA we make. So we run it on a gel electrophoresis. Alice Birkin got an enormous number of emails from me talking enthusiastically about how to dye things and how to look at them with various filters. But this is we're old school. We take gel pictures. We also want to verify that these samples are fit for downstream molecular biology applications. And so we use a degenerate set of primers against alu to quantify the bulk alu content of half of your genome as alu sequences. And so it's a convenient way to actually quantify the performance of the DNA in molecular biology.
Now, this process is a wonderful example of necessity is the mother of invention, because Chris developed it because he needed a larger amount of cfDNA in his research for liquid biopsy assay. And so it came about because of that. And we realized that there is no other source of human plasma on the market, believe it or not. All of the cfDNA
Human cfDNA, not plasma.
Sorry, human cfDNA. Yeah. The human cfDNA that you can purchase comes from is a cell culture product. So this is native, if you will. The other nice thing that sets us apart from what you can get on the market today is that there is no or very little due to our bead separation process, there is very little, I'll just use my hand, of the high molecular weight genomic DNA that you would ordinarily see up here. So that is a really nice feature of this product.
We have a website. If you want to buy any, let us know.
So as Chris said, we are really, we take, set over here. Can't see the slide. We listen a lot to our customers, and this is a good example of a request that we had from a customer that asked if we could blend cfDNA from two unrelated individuals and use it for their assay as a way to calibrate their performance. This particular customer has a liquid biopsy assay that is used to monitor the health of a transplanted organ, in this case, kidney. It was noted that that the increase in cfDNA from the organ, from the donor, correlates with a rejection of the tissue itself. So this is a predictive assay. Monitoring the cfDNA levels allows you to detect the potential rejection before it turns into a full-blown rejection. And that then gives you time for treatment and for just treatment before it's actually
Before
rejected.
organ damage happens,
Before any organ damage. So the way that we did this was we took this, as we said, cfDNA from two people that were unrelated. One represents the background, that's the recipient, and the other is the spike in, the donor. We then genotyped it and looked at 1,369 common SNP genotypes. Out of those 1,369, we then looked at 356, identified 356 where the background was homozygous and the spike in had an alternative allele. And then we made the blends, and the blends were based on just a mass basis. But then with this information, we were able to genotype again, and we were able to determine what the minor allele frequency of the spike in markers were so that we could more accurately characterize what the actual sample percentage was. So for example, we had a target of 0.5%, and after we did this whole process, we came up with 0.57. So the customer then is given a certificate of analysis that has that CI that they can then use when they run the assay.
This is an example of a ripple. Who knew that we were going to get involved in organ transplant? And yet, you know, this has been a great product for us, and that our customers are really grateful that we produce it for them.
It has. It's been. It's getting more notice. It really is.
On sort of the big picture, sort of public health front, I worry a lot about liquid biopsies, and I worry a lot about trust in liquid biopsies. And I worry a lot that there's a lot of money to be made in liquid biopsies, and therefore there's an opportunity to misrepresent your capabilities to the public. And so this is my motivation for thinking about oncology reference standards. And my hope is that some degree of regulation comes to bear on this industry. And in order to do that, you actually have to have some measuring stick of how well does an assay work. And in order to make a measuring stick of how well the assay works, the analyte that goes into that test should be the same thing that you're going to test in a patient. And so I see an opportunity for us with our cfDNA manufacturing to contribute to this really important potential near-term regulatory environment by mixing together our core isopure cfDNA with synthetic biology. And by synthetic biology, I mean making G blocks that are manufactured by integrated DNA technology, blending them together, and then manufacturing a fragmented version of those G blocks that's reminiscent in size to cfDNA, such that you can take a known set of markers and blend them into cfDNA at known percentages and make tests where you know what the truth is. And so, you know, this is our last sort of sciencey slide, but this is something that I'm actually putting a lot of energy into right now. And it seems like a simple idea. It's really actually really hard.
Okay. Well, our final two slides are just our thoughts on both becoming an entrepreneur and then also growing a science business. The first point that we wanted to leave you with was and we brought this up earlier, ensure that before you go into your own business, that you are financially stable. If you think that you're going to be able to pay yourself while you're having your business, at least initially, you'll be wrong, and that will create a lot of stress. So make sure you have a nice, comfortable buffer before you start a venture like this.
One of the things that we've learned the hard way is, while you cannot do everything yourself, and that's something that we're really struggling with, in all honesty, is we try to do everything ourselves. While we can't do everything ourselves, it's really important to educate yourself, at least to the point where you can be dangerous, about what other people are doing within your organization, so that you can evaluate performance. And that has been a lesson for our startups that haven't worked out so well.
Right. And make sure that you have a viable prototype, especially before you take any investment capital. And if your invention is something that is a process, make sure that you have it worked out from the beginning to the end. And also make sure that, of course, that there's a market for whatever it is you're trying to start your business with.
I think one of the powerful things for us is to understand motivation. We, both of us, feel like what we're doing is important. And because it's important, it also is enormously satisfying. We run into individuals that hope to become wealthy by entrepreneurial startups. And the fact of the matter is, there is no guarantee that you will be successful. But if you love what you're doing, you get an enormous amount of reward no matter what happens.
And owning your own business is very hard work. And often there's very little glamour. Answering emails at 2 in the morning is kind of a slog. And so be prepared for that.
But it's fun too.
Yeah, slog is maybe a negative way of putting it, but it is not easy.
And
all times.
sort of in keeping, just to finish the last point here, just in keeping, if you were successful once, it doesn't mean you're going to be successful again.
Right.
Ouch.
Can't make those assumptions. And then if you are lucky enough to actually have a business, what are our thoughts about growing that business?
And in particular, a science business, right?
In
We wanted to
particular, a
point it
science
at
business. Yeah, if you're growing a science business. Your go.
It's me? Oh,
Yeah, you're up.
conserve your resources. So we're really, in retrospect, really pleased that we had a sketchy lab on Aurora Avenue in front of the fentanyl
We're
dealership.
pleased to be out of it.
It was.
Yeah. Yeah, but that is how we viewed it. Obviously, we were very frugal, but even if you are lucky enough to amass more funds, be careful with them. Don't go hog wild. Just plan for a rainy day. We also wanted to mention that it's really important, if possible, to have peer-reviewed publications. So wherever possible, you should strive to have those, because they lend credibility to your company, and they also are really useful if somebody has questions about your process or more information that's needed. You can just hand them a peer-reviewed publication.
It's a
So
royal
that's worked
pain
out
to
very
make
well for
them,
us.
but man, is it the gift that keeps on giving
Yeah.
once you have them.
Yeah.
And as we illustrated with getting into the organ transplant gig, it's really important to listen to your customers. And I actually get frustrated when I go out into the biotechnology world, where a salesperson will say, this is what we have available, and what you're describing, Dr. Raymond, has nothing to do with us, so we can't help you. And our philosophy is, if you ask, we're going to do everything we can to accommodate.
Right. This next one is one that's pertinent for us. Not everybody will agree with this, but for us, I believe that growing organically is the way to go. So don't think that you were just going to start an instant business by having an idea, adding money, and poof, you have a business. It does not, I don't believe, work really that way. So allow yourself to be small, be content with that, and then just let your business grow as it will.
One of the things that our kids heard a lot as they were exiting high school was, follow your passion. Well, if you're a kid, you don't know what your passion is. And Fenella and I recently heard a wonderful YouTube where the guy basically debunked that theory, and he said, no, get really good at something, because when you get really good at something, you become passionate about it. And we look back at the picture of the Institute of Molecular Biology 40 years ago, and I had no idea that some, 4 decades later, we were going to be really passionate about circulating cell-free DNA. But we are, and that's actually a really cool thing to be involved in.
And last but not least, try to keep your company going as much as you can, as long as you can, because longevity lends credibility. Even if it's just moving along on a shoestring, just still being there allows you to build a reputation. And you'll never know when a customer that you might have had 4 or 5 years ago comes back because you're still in business. And that concludes our presentation. Thank you very much.
Thank you, Chris and Fenella. That was awesome. Thank you for all
Thank
those
you.
really thoughtful lessons. I think they're really applicable to what a lot of people are doing. Obviously, a key to your success has been great chemistry in the lab and between the two of you. And I appreciate how you worked in family and all that. I did peek over at my wife over there thinking about what she would say about developing a lab in our basement. But fortunately, in the night campus, we have startup space, so people don't necessarily have to do that. All right, so we have some microphones going around for people to ask some questions. I think I'll just start with one while people are thinking. As you were presenting this, it occurred to me, especially as you got more and more efficient at generating cell-free DNA and so forth, you're generating tons of information, right? And then you're trying to use it in a predictive sense. So my question is, how much has data science become part of your business, and how did you integrate that, teach yourself, that, and make that a part of what you were doing?
That is I could have paid you for that lead-in question. It's part of why we're here. Part of why we're here is because your night campus supports an incredible training opportunity for kids to go into computational biology and computational science, and it's incredibly important. And to this day, one of our greatest unmet needs is really marrying molecular biology and chemistry with data science. And I think we're not good at it. And I think it's an opportunity for us in the future. And what you're doing here is fantastic.
Yeah, that actually gets to the point that we made at the end about having a completed prototype. That was a gap in what we could do. And so, yeah, it's very, very important to have that.
And I think, another reflection that I have, and again, I said this to you earlier, it's one thing to be mom and pop and have a science opportunity in your basement. At some point, you need help. At some point, you need to get different minds involved. And that's our challenge to the future, I think. Yeah. Hey. Hi. Yeah.
Thanks. Really interesting talk.
Thank you.
Maybe to that point, following up on bringing in additional expertise, other resources, can you talk a little bit more about what motivated you to create Salish? While you still had Ripple going, kind of what was the strategy around that? What was the motivation? Because
we thought
from a
that
certain perspective, you're already small, and
right.
Is that going to dilute too much
It was really, we thought about it. We thought about keeping it all one business, but then we realized that it was kind of a natural split out because the Ripple was getting to be more of a cfDNA product company, providing cfDNA products to customers. And the liquid biopsy assay almost stood alone. And in particular, the oncology diagnostics part of it was what we really wanted Salish to address.
And so the aim of creating Salish technology was to make a lab that could produce prototype information that would be acquired by a larger venture. A lot of big companies have a difficult time actually innovating, but they're good at acquiring. And so there's this niche where you can be a startup, you can make foundational technology And then your hope is to hand it to people that are better at globalization and execution. And that was our hope with Salish. We never got good enough as a prototype, and the burn rate was so high that we made, I think, the wise financial decision to stop going forward.
Right.
Great question.
Mhm.
Thanks. Just shout it out.
Yeah, well, I'd love to hear more about how, I mean, it sounds like with Ripple, your customers were in your mind, your target customers changed, and how that, you talked about listening to the customer, but you also ended up sort of who the customer was evolved, and I'd love to hear more about how that worked.
We were kind of naive. We just knew that initially we knew that CFDNA was a great product for us. And so we reasoned that it would be for other people as well. And that proved to be true. And then later on, after we had been selling just the CFDNA alone, then we started with the customers that were doing the organ transplant. And as Chris mentioned, now we're thinking more just for oncology reference standards.
And I think it's fair to say that our product portfolio at Ripple is a little bit like a hermit crab, where we find a little bit of seaweed, we stick it on our shell, and then we find another something. And so our portfolio of offerings has grown, but also our willingness. Every customer asks us for something funny. You think you figured it out, and then they want a panel of diverse individuals that are all underneath 5'5", and you go find those people. And but the funny thing is, those asks keep repeating themselves. And so after a while, instead of being a custom one-off, you're like, well, let's just make it a product.
And we're actually excited because we did spend quite a bit of time growing Ripple. And now we're at a point where, and we got kind of diverted with Salish, and now we're at a point where we can focus our energies again on Ripple, and we feel like we can really start to grow and ask those very questions to customers. What are your needs, and how can we satisfy that?
Another thing that I'm really excited about the Night Campus. You are doing all the right things, and one of the things that you have here is incubator space. And it's critically important to a business. It's critically important to a business to have some place that's safe and operational and effective, that allows you to test ideas without going completely bananas broke. And so, right on. I'm wildly enthusiastic about your path.
Thank you. Well, the hour has flown by. If I could ask one more question and bring it back to the students, because the two of you have been such incredible mentors to our students and IMB students. So you gave some great advice to get really good at something. And I'm going to steal that, because I'm one of those people that says, follow your passion. But of course, you didn't know you were going to be passionate about cell-free DNA. Who would, right? So just, do you have any other parting advice for our trainees for what they can do during their studies now to prepare for a pathway similar to yours?
Work hard, and that's age-old advice, not flashy, but find something that you're able to do and work really hard at it until you're really, really good at it. And like we were saying, then you will love doing it.
But I
and
think
it'll become exciting for you.
I think in fairness also, we put in that period of 20 years, and anybody who has young children, the good thing is you won't remember the next 20 years. And so, I credit Fenella actually with being financially responsible. And so at the time when you're working for somebody else and you're garnering experience, to salt away money is really, really useful. And it served us in good stead.
I think a great lesson I took from your presentation also was resilience, and not being frustrated and shutting down just because you've run into a pathway that doesn't work, and just keep at it.
So. It's almost thinking, and this sounds kind of Pollyannish, but thinking about those so-called failures as new opportunities. Just re-looking, refiguring in your mind what this means, how it could grow, how it could change.
And you made that point so well. Yeah. So, all right, well, we better wrap things up.
I want to thank all of you for being a really enthusiastic
Now
audience.
you're stealing my speech.
Really fun. Sorry.
He does that. He's terrible.
Okay.
So thank you. Thank you all for coming. This is the last lecture of the academic year, but look for us coming back with more speakers in this series next fall, as well as our distinguished lecture series. So let's thank Chris and Fenella again for an amazing talk.